Okay, I'm just going to give a bit of a demo regarding inverse Laplace transforms, and I'm going to do it through the use of the North Carolina State University Virtual Computing Lab. And if you don't have a home or student edition of Maple, you can use NC State's Virtual Computing Lab, and it will have an older version of Maple instead of the 2019 or 2020 edition. It's going to very likely have, I think it's like the third edition of the 2017 model. And anyway, to be able to use the NC State VCL, you'll need an app installed into your computer, and the one that I use is a MacBook Pro, and it is going to have the Microsoft Remote Desktop. That's one of the portals, I guess you can say, in order to activate access to NC State's Maple. And for what we have, and if we look into the Blackboard page, and I added the NCSU VCL into the menu, and if you were to click on that, okay, and inside is going to be the web link to click on, and this will take you over to NC State's website. And what you will do here is make a reservation, and you might have to choose Johnston Community College. Okay, there's like an intermediate page, and since I've already been through it, it is taking me right away to the current reservations, and with the Johnston Community College heading and banner. And in terms of making a reservation, okay, so it looks like, yeah, we'll go with Maple 2018. Okay, so they have Maple 2018. That's the newest edition that they have. And we'll go ahead and create a reservation. Okay. And here we're looking at waiting for the server and all to be activated, whereupon Maple would become available. Okay, so it looks like the NC State version of Maple is available. Okay, so if we connect, okay, and you have these items, you have the user ID and the password, and you want to go ahead and jot that down. I mean, whatever password you're given, not what is on the screen. You'll be given something else if you go through the NC State VCL. Okay, and so what you're going to do is that once you have the password provided, you have get the RDP file. Okay, so just click on the link. It might take a little while. Okay, so it's asking for the password that was just requested. And it's now configuring. Okay, so it looks like it's going to be a bit of a slow process in comparison to the Maple 2019 Home Edition, but okay. And here we have Maple 2018. So you just click on the app, and now it is loading. All right, so for what we have in the development, okay, and just as we have done before, we'll go into worksheet mode. Okay, so we have with the opening statements, we have with int trans, in parentheses, hit colon, and just going back to Laplace. Say if we're looking for the Laplace of the sine of 2t, and we need the angle in parentheses. Okay, so we have the function in terms of t, and the Laplace we'll have in terms of s. So for the Laplace of the sine of 2t, okay, that comes out to 2 over s squared plus 4. Now, if I go with the Laplace and say we have In this case, we'll say we have 2 times e to the, let's say e to the 3t. And we have followed by the addition of t squared. And we'll say we have minus 4 times the cosine. And we'll say we have of 4t. And so again, we're going from terms ns or terms nt to s. And for the Laplace of this, okay, we have 2 over s minus 3 plus 2 over s cubed minus 4s over s squared plus 16. Now, if I work in reverse, I have the inverse Laplace. And I think I can copy this. Okay, so we're going from terms in s to t. And for the inverse Laplace, we're back to the sine of 2t. And taking the inverse Laplace, say if I have, with this collection of terms, and for the result, okay, so we have 2 times e to the 3t plus t squared minus 4 times the cosine of 4t. And that's all there is in Maple in the case of the inverse Laplace transform.